Thank you, Dr. Ong, for your insightful sharing. In the next section, our third keynote speaker will be delivering his keynote address entitled The Rise of Self-Reconfigurable Maintenance Robots. He will share the ongoing efforts at the SUTD towards the design, development, and deployment of self-reconfigurable robots using a well-defined set of deployment use cases in the maintenance domain. He is currently an assistant professor with the Engineering Product Development pillar at SUTD, working on robotics with an emphasis on self-reconfigurable platforms as well as research problems related to robot ergonomics and autonomous systems. He has published more than 150 papers in leading journals, books, and conferences. He is a co-founder of LionsBot and Oceania Robotics, robotics companies that develop a wide range of autonomous robots for specialized niche industries. May I introduce our third speaker, Assistant Professor, Engineering Product Development pillar, Dr. Mohan Rajesh Elara.
Good morning, everyone. I'm very glad to be in this forum to share the progress and insight into the rise of self-reconfigurable maintenance robots, and specifically to provide an insight into the research, development, and commercialization initiatives at our road lab at SUTD. Let's go to the slides now. This talk will provide an introduction to various robot platforms that we have and the specific application that we target. Most of these work are funded and supported by the National Robotics Program, and we are very thankful for all the support they have been provided over the years. So at our lab, the road lab at SUTD, we focus on three major research thrusts: design for robot, design of robot, and design by robot. In design for robot, we focus on designing efficient and effective robots for specific use cases, just like many other robotics labs in the world. Our specific interest is in self-reconfigurable robots. These are robots that have the ability to change their form from one to another in order to overcome the difficulties in the terrain that they navigate or the tasks that these robots perform. And by doing so, these robots offer superior performance compared to the fixed form robots, and also provide numerous benefits in terms of versatility and the ability to handle multifunctional roles. So beyond that, our lab focuses on design of robots, where we pioneer a number of efforts in terms of delivering guidelines, principles, tools, and techniques, where we bring together architects and interior designers in delivering robot-friendly infrastructures. And with this domain, we are looking to develop built infrastructures that are friendly and inclusive to robots. We see an increasing trend in adoption of robots, spanning from cleaning, inspection, pest control, surveillance, logistics, and many more. With this increase in robots, we are looking to have built infrastructures that offer inclusivity for the new stakeholders that are entering the buildings. The third domain, the design by robot, we are looking to leverage on the recent emergence of AI tools and developments in AI to deliver design tools that can help robot designers to design efficient robots. Here, we are developing AI systems that leverages on the wealth of literature that exists in robotics to propose design solutions, from morphology to placement of sensors to configuration for a particular robot platform for robot designers. So robot designers with ease can choose the products and platforms. So collectively, we look at design for robot, design of robot, and design by robot. And we are the only lab, the first of its kind, that focuses comprehensively on all three aspects. So now I will introduce some of our niche robot platforms that offer numerous benefits while leveraging on reconfigurable abilities. To this end, we have developed a number of research outputs that are fundamental and groundbreaking, all the way ranging from mechanism control, perception, and autonomy. The very first platform that I want to introduce is that of Tetro. Tetro is a shape-changing robot that derives inspiration from Tetris, and it tackles the problem of floor cleaning. Floor cleaning is a difficult task to handle. There are numerous robots in the market, commercial ones, that handle this problem. And these robots come in different shapes, size, and form factors. Some of them are circular, rectangle, square, and so on. The platform that we developed, the Tetro, derives inspiration from Tetris and is capable of changing to one of 7 shapes. So here we look at the mechanism that is capable of switching to one of 7 configurations, as you can see here. Perception abilities that allow the robot to look at the environment, observe, and to assume efficient form factor. What you see here is a commercial robot, and the company claims to have sold over 100,000 units, but it has a lot of deficiencies when it comes to accessing spaces. With Tetro, we empower the robot with the ability to perceive the environment, shapeshift to assume a form factor that will enable it to maximize area coverage. Tetro uses the same type of sensors, motors, batteries on board, controllers, with the only difference that the robot hardware now allows it to shapeshift, and we have algorithms on board that enable it to assume the right form factor to maximize area coverage. What you see here is a snapshot from our experiment where the commercial robot is not able to move over to the other side of the chair just because of the constrained space. The total area covered is less than 30% as observed by the overhead camera. This scene is common when it comes to deployment of robots in office spaces or in residential homes. With the case of Tetro, as you can see, the platform assumes the shape of L to access the area underneath the chair. It assumes the shape of I based on the availability of space and to cover and clean areas over 95%. With commercial platforms, the focus is often on optimizing the cleaning payload. But if a robot simply cannot access a place, it cannot clean a place. So here at SUTD, our focus has been on enabling these cleaning robots with the ability to shapeshift so that they can access spaces and clean spaces. So we have run a number of experiments to prove the superior ability of our Tetro robot compared to various commercial and research platforms. Here, the development not just focuses on mechanism, but a lot on autonomy, algorithms that enable the robot to interpret the environment and to assume optimal form factors. So moving beyond the floor cleaning robots, we have developed fundamental research capabilities that empower the robot to offer superior performances beyond horizontal floors. The second robot I want to introduce is that of Tetro. Tetro is a shape-shifting staircase cleaning robot. When it comes to floor cleaning, there are over 100 robots in the market that offer cleaning roles, be it professional or residential class. But when it comes to staircases, there is none. The same is true even in research domain. Very little effort has been done in developing robots that can access staircases. At SUTD, we are developing Tetro, a robot that is capable of accessing floor as well as staircases. The robot is equipped with a full suite of sensors that enables the robot to detect and classify staircases into 10 different types: straight, left-leaning, right-leaning, spiral staircases, and many more. With the classification, the robot then generates appropriate control primitives that allow the robot to efficiently climb, and in this case, clean, as we anchor Tetro to maintenance and specifically cleaning application. The robot also has algorithms on board to interact with the people that ascend and descend the staircases. So Tetro is in the process of being licensed to a commercial company, which is looking to bring the platform to market within 1 year. So beyond Tetro, we have moved to also capture the vertical spaces with our Mantis class of robots. There are facade cleaning robots in the market, and also research has been done to some degree to demonstrate robots that can move in vertical facades. But with all these platforms, they can clean a single panel and would require human intervention to move the robots from one panel to another panel. Imagine the airport gates where we have a number of panels, or a high-rise building, again, a scenario where we see a number of glass panels, often separated by a frame. In such cases, if a human operator have to intervene every time to move the robot from one frame to another, that is going to result in a huge drop in productivity. To solve this problem, we have developed fundamental mechanisms and control approaches that enable the robot to clean a single panel, detect the frame, and to move from one frame to another all by itself. By doing so, the robot significantly improves productivity compared to existing research and commercial platforms. So the two lines that you see are only for safety, and the robot uses indigenously developed impeller mechanism. Is an inverse of propeller that the current flying machines uses. So it uses the principle of impeller to adhere itself to the glass facade. And again, we have put in a numerous effort in research and development to have optimal amount of pressure exerted for the robot to move and clean. Also, a number of approaches has been iterated towards human-robot interfaces so that the robots can be translated to commercial setting with ease. So it's not just about glass facades. We have also shown scalability of our Mantis robot for application in aerospace domain. So what you see here is an adapted version of the Mantis, which we call Chiropter, to tackle maintenance, inspection tasks in aircraft setting. So Chiropter is capable of going around the fuselage of an aircraft and to transform from the wing to the fuselage. So to this end, we have developed custom mechanisms, control approaches, autonomy approaches, perception strategies that allows the robot to navigate in the exterior surfaces of the aircraft while meeting the stringent requirements in this conventional domain. The idea is to push forward to develop a truly autonomous robot that is capable of going beyond inspection to handle also cleaning. So we have developed also computer vision and AI packages that can detect abnormalities in the exterior surfaces of aircraft. This project has been conducted in collaboration with ST Aerospace. So beyond the small scale platforms like the Chiropter, Mantis, H-Tetro, and the S-Tetro, we have also developed platforms that are large scale and belong to the vehicle class. Panthera is a platform that we are developing for cleaning of pavements and sweeping of pavements. So Panthera is an autonomous reconfigurable robot that has the ability to compress and expand in response to the varying widths of pavements and the density of people in our park connectors and pavements. The platform is completely developed in-house at SUTD. The mechanisms, control, perception, and autonomy approaches that enables the robot to perceive the environment and to compress and expand in relation to the environmental observations. The platform has a payload capacity of over 300 kilos that allows the robot to easily be scaled to logistic mission. So the platform has a number of unique abilities, including what you see now. The robot is capable of compressing and expanding while in motion. For a robot like a pavement sweeping platform, this is absolutely essential. Imagine the robot observes people that are walking, running. It is important for the robot to be versatile, to compress, allow for the people to pass, and then expand and cover pavements or park connectors that the robot is sweeping. The robot is currently being test bedded in SUTD campus, iterated with the idea to scale up and run trials together with the NEA, the National Environmental Agency. The developments here span beyond mechanisms and control to also take into account human interactions, detection of human intention estimation, and for the platform to react with autonomy cues to this end. So another exciting platform that is being developed at our lab is that of Scorpio. So the project was originally funded by MINDEF at the Tamasak lab with the original purpose targeting urban reconnaissance mission. Scorpio is a miniature rolling, crawling, and wall climbing robot. The focus here is to develop a miniature robot that is capable of performing urban reconnaissance mission. We developed the very first platform that is very small in scale, less than 10 centimeters in rolling diameter, that is capable of crawling, rolling, and wall climbing locomotions. The platform had a full suite of sensors on board to detect objects of interest, human, and activities within a defined space. So with all these developments happening, we had a keen interest to go beyond intellectual output to also make socio-economic impact. So the lab made concerted effort to inspire startup that can leverage on people that are trained in the lab, SUTD students, SUTD researchers, and our graduates, and also to translate IPs that are developed in our lab so that it can benefit local SMEs, translate into products, contribute towards job creation, and be exported as products to other markets. Our very first effort is that of LionSpot. So LionSpot is a company where I'm a co-founder, and I co-founded the company together with Dylan, who has been in the cleaning industry for almost 20 years with his Super Steam. That is a major cleaning equipment distributor in Singapore. So LionSpot was established in 2018. So currently the company has over 65 engineers spanning all the way from mechanical, electrical, electronics, computer manufacturing, all. The company manufactures robots here in Singapore, very close to SUTD at Changi. We develop a number of core technologies in-house, spanning from the mechanical design, the PCBs, the power systems, the cloud architectures, the autonomy stack, everything is done in-house. The robots are produced in Singapore to meet emerging need in the cleaning industry locally here, and also to export the robots to overseas and countries that face same difficulty in meeting the manpower needs and productivity improvements in the traditional industry of cleaning. So currently, LionSpot has deployed the robots in many niche sites in Singapore, spanning various industries from healthcare to aerospace to universities, schools, factories, and beyond, with very positive feedbacks, and with our number of deployments increasing over the years. So beyond that, LionSpot has also exported the robots now to 24 countries, and our deployments are expanding. With COVID, there is increased need for cleaning, and the frequency of cleaning has increased, and our robots from LionSpot are working hard to meet the gap and to provide support in this emerging and evolving situation. So here there is a short video introducing our LeoBot class of robots from LionSpot.
Baron is a 925 hours robot operator from the future. He uses the Lions Clean app to manage his LionSpot cleaning robots. Leo Scrub specializes in scrubbing and drying floors. Designed to prevent collisions, he comes with a full suite of safety sensors. Deployment using the Lions Clean app is easy. Being nimble, she can access narrow doors and tight turns readily. Leo Mop cleans silently and uses 70% less water than other machines. Together with Leo Scrub, they form a smart team. Leo Vac cleans both hard floors and carpets. Besides the powerful cleaning performance, she brings joy and laughter everywhere. Leo Pool performs quick swap of 660-liter bins to dispose trash effortlessly. With 24/7 cloud support, Darren can get assistance anytime, anywhere. Darren's dream has become a reality today. Bringing you the robots people love, LionSpot.
So with our successes in LionSpot, we wanted to turn our lab into a catalyst that can inspire many more startup companies in the domain of robotics in non-conflicting domains. So we can have an ecosystem of robotic company here in Singapore. So our next effort towards inspiring startup came with that of Oceania Robotics. So Oceania Robotics is a company that is into marine pest control and landscaping. The company produces designs and manufacture robots that target productivity improvements in a number of ruggedized and hazardous work processes in this domain. So the company focuses on marine, where specific work processes targeting hydroblasting, grid blasting, and benchmarking are replaced with robots that can be teleoperated by people. These are work processes that are highly hazardous and involve ergonomically difficult work processes. With the robots that Oceania is deploying, the ergonomic conditions are significantly improved, making these jobs attractive for our youth. So here is a video of our hornbill class of robot that performs grid blasting. So from the video, we can see how difficult the environment becomes when the task is being performed. Currently, this process is completely manually done, where an individual holds the nozzle and fires the grid at the surface, removing the paint or the biofoul. With robots, the process can be automated with human in the loop, an individual teleoperating the robot from afar. The process efficiency, for the productivity, and the ergonomic situation can be vastly improved. So here with Oceania, we are developing platforms that not just improves productivity through inclusion of robots, but also novel mechanisms and control approaches introduced to force multiply the productivity benefits. So with this case specifically, the robot uses a double nozzle instead of the traditional single nozzle approaches, doubling the area covered for a single swing. And beyond that, the robot also offers autonomy, very first of its kind in the market, where a cell can be defined, like let's say 5 meter by 5 meter or 20 meter by 20 meter, and the robot would go zigzag spiral covering the given area, performing grid blasting, hydroblasting, or benchmarking tasks. So beyond that, with the recent trend and need in the pest control industry, because of the emergence of dengue cases last year, the company has scaled up to produce robotic solution to this much needed market. So the current approaches in mosquito control are often labor intensive, like let's say the case of fogging is a labor intensive work process, and robots can automate a number of these work processes, and also to save people from mosquito bites and spread of dengue. So here, the Dragonfly class of robots are being designed and manufactured by Oceania to target mosquito control applications. The robot carry indigenously developed payloads that attract mosquito, trap them, and kill them. To this end, there is 4 layers of attractant modules on board the Dragonfly platform, spanning olfactory, the smell, the light, the motion, and also the colors are used to attract mosquitoes and to trap them and to kill them. The platform has AI and computer vision on board so that the robot produces daily reports or periodical reports when it comes to detecting hotspots in a given place. For example, with Dragonfly deployed in a primary school or a university campus like ours at SUTD, the robot will be able to provide mosquito hotspots that are upon deployment over an extended period. And also, importantly, to benchmark the reduction in mosquito over a given time. With current approaches like fogging, the fogging process is done and it is assumed that mosquitoes are taken care of. But with Dragonfly, the robot produces daily or periodical reports to show that the number of mosquitoes in a given area is decreasing over time. The robot offers also a number of other services enabled by its cloud platform. So here, now Dragonfly robots are being deployed and piloted together closely with a number of our partners. So this video shows our recent deployments at the company's round market Hawker Center, working closely with the company's town council. So the platform can be deployed in a number of modes. So one of the recent recognition for Oceania is that of being the only robotic company that will develop and deliver a vertical garden maintenance robot for our Singapore pavilion at World Expo Dubai 2021. So with our World Expo Dubai, our Singapore pavilion has a huge vertical garden facility, and the robot Eurodella that is developed and manufactured by Oceania will be deployed to perform laborious tasks such as pot replacement, monitoring of plants, fruits, flowers through use of onboard AI and sensor packages. So we are very proud that Oceania Robotics and with technologies that are licensed transferred from SUTD are part of this platform to be demonstrated at our Singapore pavilion to the world. So here with developments with our lab at SUTD, the Road Lab, and our inspired startups, LionsBot and Oceania, we are looking to expand to inspire a steady stream of companies and also translation of IPs and the fundamental research to companies in Singapore so that we can produce waves and waves of robotic products that can be translated and exported to other countries and result in big job creation here in Singapore. Thank you.